Hey everybody, welcome. Today you guys have been thinking through inclines. So I want to do a problem to work with you here. So again, if you're stuck on stuff, reach out, let me know, but also look at the resources I've given you. I've got those two AP Classroom ones. I also have a teacher who did it. I thought it was really good how he thought about the reference frame. So I think it's a really good one. So those three videos there to support you. But if those aren't working for you, reach out, okay? So you're not alone, all right? But at the same time, go to those first. So welcome to here. So we're gonna tackle this problem. So we're gonna kind of walk through this. So I've got a 5 kilogram box and it's on an angle of 35 degrees. So start there, draw a picture. Straight down would be the weight force. I'm just gonna label it as M times G, or you can write it as a W or as a force with a little g. Those all work. I also have a normal force, not a natural force, normal, okay? Normal is a math term that means 90 degrees. So when things are normal, they're 90 degrees to each other. The surface can only push 90 degrees as a normal force. So if there's no friction, like we have in part A, there's no friction up the ramp. But what we are gonna do is we're gonna split up. Let me draw that better because this is a huge idea. Okay, I'm going to split this up into the forces going into the ramp and down the ramp. So the gravity is pushing, part of its force is pushing into the ramp, part of it's pointed down the ramp. So into the ramp is mg cosine theta. The force down the ramp is mg sine of theta. That was great what Greg Jacobs said in the video. He said the way you remember it is that mg sine slides. Sine slides. That was pretty cool. I'm going to start using that. I just did. So in this problem, the normal force is pointed that direction, but the mg cosine is into the ramp. Those are in opposite directions, so the normal force is going to equal mg cosine theta. So it's 5 times 10 times cosine of 35 degrees. Okay, that's a 10. I had a really hard time writing today. Okay, so I want to just emphasize a couple things. If you're using a TI-30X, one of my favorite calculators, make sure that it says DEG at the bottom, right there. That means degrees. If it says RAD, hits the DRG button, and you'll get yourself where you can hit to degrees. Okay, and so just get back to the home page, and you are going to type in 5 times 10 times cosine of 35. I get 40.95. I'm going to round that to 41. Okay, 41 newtons. Notice your weight force in this problem is 50 newtons. It's 5 times 10, it's 50 newtons. Your normal force is not equal to the weight because you're on a ramp. Okay, it's very important. So if you're sitting there going, how come sometimes I slip when I'm on a hill, but I don't slip when I'm on a flat spot? Okay, here's why. If your normal force gets smaller, that means your friction will get smaller too. So that's when you'll have more slippage. So the other one is if you're using a T84 or a T83, make sure you hit mode and it says, let's make sure I get to the right line, degree. So if you are typing these problems, you're not getting the right answer, that's what I would do. If you're using a different type of calculator, reach out to me. But these are the two that I see the most in class. So again, just reach out and let me know. All right, so how do I find the force down the ramp? That is mg sine of theta. Mg sine of theta, 5 times 10 times sine of 35, which is 29 newtons. Let me double check because we are recording. 5 times 10 times sine of 35, 29 newtons. Now, the next question is a leading one. What is the acceleration? Okay, here's the key. What on this picture is driving it down the ramp? That's your mg sine of theta. That's what's driving it down the ramp. So your acceleration is going to be based off of that. So if I write down the beautiful equation, F net equals ma, I can say mg sine of theta, that's the force down the ramp, equals ma. If I didn't know what the mass was, I could cancel it off and just plug in g, plug in sine, and I get acceleration. Since we have it, we're just going to use it. So the force down the ramp is 29. My mass is 5. I solve for my acceleration, which is 29 over 5, 5.8. Okay, so I'm accelerating at 5.8 meters per second squared. Notice, even without friction, It is not accelerating at 10. Okay. Part B. There's enough friction to slide at a constant speed. There's your clue. Ready? Constant speed. What does that mean? Constant speed means that the force down the ramp, mg sine of theta, has to equal the force up the ramp, which is your friction. So in this problem, if you have 29 newtons pulling down the ramp, okay, how much force do you have up the ramp to go to constant speed? 29 newtons. When those are the same, your F net, since it's equal to ma, your F net is 0. So that means your acceleration is 0. Okay. Part C. What if the coefficient of sliding friction is 0.12? Whoa. This is a bonus. So if you're like, Shamir, I'm just trying to just survive. Rock on. Stop. Have a great day. But if you're like, hey, I want to see how to process this one. So you take your mu, fun equation, 0.12. What is your normal force? Since you're on a ramp, your normal force is not just your weight force. It is not equal to your weight force because it's not the same. So it is less. So force of friction is, only get a number. So we just have a number to work with. 0.12 times 41, which is about 5. Okay. I'm going to write it as the actual number so we don't confuse it with the mass. So it is 4.9. Swear that says 4.9, kids. Okay. Oh my gosh, it's getting worse. All right. So now if I think about my F net equals ma, I have a force down the ramp. I have a force down the ramp. I have a friction force up the ramp. And I'm going to subtract them because they're in opposite directions. So force down the ramp is 29. The force up the ramp is 4.9 equals ma. So 24 over 5, I get roughly 5. Yeah, about 5. So I get an acceleration of about 5 meters per second squared. I am rounding. That's pretty close. Okay. So notice when they give you a coefficient of friction, you're going to plug it into your fun equation that relates friction, mu, and normal. But the normal force is not your weight force. Okay. Let me think. There you go. That's all I got for you today. Okay. Let's keep talking. Keep going, guys. You're doing it.